Hey, I'm Mr. Coker with Foundations of Algebra, Lesson 7-3, Literal Equations. So, a literal equation, what that means is it's an equation where we're solving for a variable, but we have more than one variable. We're only solving for one of them. Most literal equations that we work with are going to deal with just variables, although sometimes they have variables and numbers. And I'll show some examples. Most important thing with literal equations, solve just like regular equations. First one we have is this one. It says x minus y equals m. And every time you're given a literal equation, it will tell you which variable you're solving for. This one says for x. So we're solving for x. So just like with a regular equation, we want to get x by itself. I'm going to start by drawing a line down the middle of the equal sign. I'm going to look at what operations are taking place with x. We have minus y. So we're going to take the opposite of minus y, which is plus y. Whatever we do to one side of the equation, we do to both sides. So I will add y on one side, add y on the other side. My y's cross out, and I'm going to wind up with x equals, and over here, this is the part that sometimes trips people up. We have m plus y. Remember that we cannot combine like terms. We can multiply or divide like terms, but we cannot add and subtract them. M and y are not like terms. Therefore, our final answer is just going to be m plus y. X equals m plus y. That's it. So essentially we are manipulating the equation, moving variables around based on inverse operations. The second one I'm going to do is a two-step equation. This time we have xh plus m equals z, and it tells us to solve for h. So this time we want to get h by itself. Treat it again just like you would a regular equation. You can get rid of either the x or the m first, but just like in a regular equation, if you with numbers, if we divide by x, we have to divide everything by x, and it makes it a little bit more difficult. So what we want to do is get rid of the m first, because it's an easier operation. M minus m cancels, and then we bring down xh, and on this side we have z minus m. Again, those are not like terms, so we cannot combine them. We'll just turn it into z minus m. Now we're almost done. We have xh. Remember that when you see two variables together, are a variable and a number together without a sign, then we assume it's multiplication. We know it's multiplication. What's the opposite of multiplying? Of course, it's dividing. So divide each side by x, and we have h equals, this is our answer, z minus m divided by x. Because there's nothing else we can do to that equation. That equation is done. Simplified. Something to keep in mind. All of the variables, we started here with 4 variables. Our final answer includes those same 4 variables, just manipulated to a different order and where we see the opposite operations. When we have a literal equation, whatever variables are in the original equation, we should have in the final answer, unless we have something like x minus x, where they subtract to make 0. We're going to have the same variables in the original equation and in the final answer, and we're going to see the opposite of whatever we had in the equation. So here we had multiplication and addition, and in our final answer we have, I guess division, we have multiplication and addition, so in our final answer we have division and subtraction. That's the way to help mentally check your answer. Last one I'm going to do is one where we have numbers, and it's also a practical one because it says to solve for y. And what I have here is an equation that we're going to essentially put in y-intercept form, or slope-intercept form I should say, so it has a practical application and it has numbers. So I'll start by drawing the line down the middle, and it says solve for y. First thing I'm going to do is take this 2x, subtract each side. We'll have 3y equals 6 minus 2x is 6 minus 2x. Those are not like terms. So 3y equals 6 minus 2x. Now divide we have 3y, so we divide each side by 3. The 3 cancels on this side, and now we get into a situation where we're actually doing numerical math. 6 divided by 3 is 2, so we can divide 6 and 3 and get 2, and 2 divided by 3 is 2/3. So we could get an answer out of that. And we could, now it's in slope-intercept form, we could easily graph that equation. So that's a practical way of using it, and it's also a reminder that if you have a lot of numbers, you're going to have sometimes where you actually have to do the math with the numbers. If you don't have numbers, you're just shifting your variables around with inverse operations. Either way, you solve it just like regular equations and just follow the rules. Inverse operations, and whatever you do to one side, you do to the other side. Do that, and you can do the literal equations.